So I think it's about time that I covered a program that I use on quite a regular basis, and that program is Git. Now, Git advertises itself as, or it advertises itself in many ways. For example, at the top, it calls itself the stupid content tracker. But what it really is it's a revision control system, which sounds fancy and useless, but it's actually very useful. All this means is that it keeps track of different revisions or changes within a project. Now, that may not sound that useful initially, but it actually is very useful. In fact, I use Git for managing a bunch of my different projects. For example, my configuration files, my website, my desktop configurations, scripts that I use, scripts and plugins, and heck, I even have some hardware projects that I manage using Git as well. So needless to say, it's actually a very useful program, and I use it on a pretty regular basis. So I want to show you guys how to use it, because I think because I put off learning Git for quite a while in the past, and I don't want you guys to make the same mistake. So first things first, you're going to need to install Git. And if you just run the git command, you'll see it'll just give you a summary of all the different subcommands for Git. But first things first, we want to create a new Git repository. So we're going to make a new directory. I'm just going to call it example repo, which is short for repository. And let's go ahead and cd into there. And to initialize the Git repository, we just run git init, and it just initializes it. It's nothing fancy. One thing you should do before you make any changes or commit anything using Git, which I'll get to in a moment, is you should run git config global and then username, and then set your username, which in my case I just set it to my actual name, which is Bryce Vandegrift. And you also want to set your user email, which I'm gonna put in my email here. There we go. And the reason you need to set these two things first is whenever you make a commit, it needs to know the author's name and the author's email address. Besides that, though, you don't have to configure anything else beforehand. So let's go ahead and actually add stuff to our project, or start our project out. So I'm going to go ahead and create a simple script called script.sh, and this is just going to be a simple shell script. That's just going to print hello world. Nothing crazy at all. So I'm going to go ahead and test this out. It should just print hello world. There we go. So now let's go ahead and run git status to see the status of our repository. So it'll just print out a few things. So it says we're on the master branch, which is our main branch. And for the sake of this video, I'm not going to be covering branches because the video will just take too long. But I'm just going to go over some of the simple stuff. So we're on the master branch. We don't have any commits yet. We have nothing to add, but we do have some untracked files, which in this case is script.sh, our only file. So we can run git add to add it, to stage it, and you'll see now this our script.sh file is being staged for the next commit. So let's go ahead and actually commit our changes. So we just run git commit, and it'll just it'll open our text editor and ask us to write a commit message. So I'll just call this initial commit because it's our initial commit. And now it'll spit out this little summary of your commit. So now when we run git status, you'll see there's nothing nothing to be done. So what exactly did we do? Well, we added this commit to our git log, and as you can see, if we run git log, we have our commit, and the commit hash, which is just a random series of numbers and letters, but it's unique for every single commit. And we have a little, some information over here that says this commit is the head of the master branch, and the author of the commit, which is me, and then my email, and then the date and time, this commit, this was committed, and then the commit message. So now that we've got a simple commit, let's add another one. So I'm going to go ahead and make some changes. I'm going to add, a line to this file. I'll just say this is a file. There we go. And as you can see, it works. So now when we run git status again, you'll see our script.sh file is modified, and let's just say we want to undo those changes. Like we want to bring it back to its original state, which was just hello world. We can run git restore on the script.sh file, and what this will do is this will actually restore the file to the state of the previous commit. So if I actually run this file, you'll see it only prints out hello world, and it's basically been reverted to its previous state. So that's actually very useful. I'm going to go ahead and actually add a separate file. I'm going to call it secret.txt, and I'll just say this is a secret file, and we can go ahead and add that. Secret.txt, and if we run git status, we can see, we have a new file, secret.txt, and let's go ahead and commit that. And usually when you write a commit message, it's just a summary of the changes within that specific commit. So I'm just going to say add secret.txt. There we go. And now if we look at our log, we see we have, 2 commits, and this one's at the very top or head of our master branch. So now let's actually go ahead and let's just say I want to get rid of this secret.txt commit, like not just the file but the whole commit. I want to go back to our initial one. So what I can do is I can actually run git reset, and what reset will do is it'll actually reset to the commit that we give it. So this hash right here, if we copy and paste that, basically what this just did is it reset to the commit hash that we just gave it, which is our first commit. So if we actually run git status, git log, you'll see we've just reverted back or reset back to our initial commit. And if we run git status, you'll see now this file is considered untracked, and we need to do something with it. So let's actually re-add this file, or actually I'm gonna go ahead and remove this file. Oh, oops, sorry, it's not in the git repo, so we just normally remove it. And let's go ahead and add to the script file. I'm just gonna say echo this is in a repo. There we go. And let's go ahead and add this script and then commit. And you can actually give it -m if you want to add a short commit message. So I'm just going to say updated script.sh. There we go. Simple as that. So there's actually 2 ways to write commit messages. So now we have these commits, but I want to share my project with the world. How can I do that? Well, you can use a Git hosting service like just for this video I'm gonna use GitHub. I don't entirely endorse GitHub because they're run by Microsoft and all that, but it's good enough for beginners. So I can go ahead and create a new repository, and I'll just call this example repo. And then you can go ahead and add a description. I'll just say this. This is a cool repo. There you go. And let's go ahead and create it. So I have all my entire Git repository local on my computer, but I actually want to put it on GitHub and synchronize changes and all that all that jazz. So we can actually copy this this URL right here, and there we go. Run git remote
git remote add, and this will add a remote repository, and we'll call this origin because this is we want this to be our origin repository, and then this URL right here, and then there we go. So now we just added that. So to actually get our changes to GitHub, we just run git push and give it the -u command, and then then we specify where we want to push it. So our origin repository, and then what branch in the origin repository we want to push it to. So for example, GitHub says the main branch, but I'm just going to go ahead and call it the master branch because it's just a better name. And it's what Git uses by default. And if I go ahead and run that, you'll see all of our stuff is pushed to GitHub. So now if I refresh the page, you'll see we have our our brand new Git repository. So nice. So next, I want to add a README file because it's usually common courtesy, or it's normal to have a README file to explain what this repo is. So I'm going to go ahead and add a README. I'll do README.markdown, and I'm just going to write some stuff in Markdown like this is an example repo. I'll just say this is awesome, and I'll go ahead and add a little emoji while I'm at it. There we go. And you can go ahead and write that. And let's go ahead and git add README, and go ahead and commit our changes. Add README.markdown. So now we committed our README file, and so in order to actually push our changes, we just run git push, and this will go ahead and push our changes to our remote repository. So now if we refresh the page, you'll see we have our README file displayed on the front of our repository. So now that's just the basics. But one thing I want to go over is changes from other people. So I'll go ahead and edit this README file, and I'll just add a line. I'll just add a line with just random crap on it. And whenever you change something in Git repository, you have to commit it. That's something you have to do. And I'm just going to go ahead and commit this right here. So now by doing that, I added an extra commit to the repository, but it's on the remote repository on GitHub. But I want to sync it to my local computer repository. How do I do that? So you can actually do that very easily just by running git pull to pull the content from that remote repository. And if I do that, you'll see the README file has been changed, and now we've had we have this gibberish, this gobbledygook right here. So we went ahead and actually synced everything with our synced with our remote repository. So now we have all these commits, and I don't want to keep track of all these commits. I want to squish them all together, or squash them, which is a git command. To do that, we can actually use the git rebase command, and rebase can actually do a lot of things, but what I mostly use it for, and what a lot of people use it for, is squashing commits together. So I'll say git rebase I for interactive, because I think it's easier just to do this interactively. And we want to rebase the head of the repository with the second commit right here. So I want to squash these two commits together. If I run that, you'll see our text editor is open with all the this huge message that basically summarizes all the commands you can do. And what I want to do is I actually want to squash right here. And so I want to basically squash these two commits together. So I want to instead get rid of pick right here, and I'll just say S for squash. And so we can actually write this file, and it'll ask us which commit message we want to keep, which message we want to keep. In this case, I'm going to comment out this one and keep add readme.markdown or MD, and so I can write that, and you can see our 2 commits were successfully rebased and updated. So now if I run git log again, we now have only 3 commits, and the first 2 were squashed together. So I'm going to go ahead and actually push this to my GitHub repository. So if I run git push, you'll see something there's an error that happens. It's failed to push because and the reason this happens is because it thinks our local repository is actually behind not updated with our remote repository, and we can bypass that by just running git push and then -f for force, so we can forcefully push it to our GitHub repository. And if I run that, you'll see there's 4 commits right here. If I refresh, it just went down to 3. So there we go. And really, that's the basics of Git. There's a lot more when it comes to this. Like, there's so many different options, so many different commands. Like, as always, if you want to, look at a list of all the things Git can do, you can run the man, or you can look at the man page, or look at the documentation online. There's a lot you can do with Git, and I might make a video in the future, more of things like branching, merging, tags, and all that. But for now, I think this is good enough for most people. So yeah, that's Git, and yeah, I'll see you guys later.